Hey there, welcome back. I hope you had a great day. Today we're going to expand our discussion about solving equations to include solving absolute value equations, but we have to do a little background work. You've seen absolute value in Algebra 1. It's worth taking another peek at. The three objectives that we have for this video includes what does an absolute value symbol look like, because we need to know when to take an absolute value. So we need to know what that symbol is. What does an absolute value mean? And then how can I evaluate absolute value expressions? So that's our goal for this video. What is the symbol? Objective 1. Look for a set of vertical bars. Vertical bars like this right here, they're going to have either a value or they're going to have an expression. All right, so notice that we have a value of 10, and these other examples are all expressions. Here our expression is x, here our expression is x plus 2, and here our expression is 3x minus 7. The expression that I keep referring to, we call that the argument. The argument. Okay, so let's identify the arguments in each of these. I'll do the first two, then you can hit pause and do the last two. The argument here is 10. Let me write that down. The argument is 10. And for this one, the argument is x. Now go ahead, hit pause, and write the arguments for the other two expressions there. Okay, let's see how you did. For this one, it is x plus 2. That's the argument. And this one is 3x minus 7. Notice that I did not use that 2 out in front. This 2, I'm going to go up here. This 2 is called a coefficient. Coefficient. And we handle coefficients differently than we do arguments, and I'm going to show you how to do that in the next video. The next objective is to actually figure out what is the definition of absolute value. It's really important to have a clear understanding of the meaning of absolute value before we actually start using it in equations. So one of the simplest ways that I have learned for students to understand is to think about it as absolute value is defined as distance. Absolute value is defined as distance. Specifically, it's the distance that a number is from 0. That number is the argument. This is the argument. So make a note, it's the argument. And then we disregard the sign, all right? It's the distance. So if you think about measuring on a ruler, and you measure from point A to point B, distance is always a positive number, or it is 0. It's never negative. Okay, so we never have a negative distance. Distance is always a positive number. That has some significant impact on what we do. So let's take a look at a number line because it's a great tool for visualizing absolute value. All right, let's first do this example A, and let's talk about the absolute value of -4. What it's saying is move 4 distance to the left of the number 0. So let's put 0 on here and then move 4 units to the left. Here it is. What we did, we got to the value of -4, but our distance is 4. What is the distance moved? 4 units. So the absolute value of -4 is +4 units. All right, let's look at B. Absolute value of 0 is the equivalent of moving 0 units. So you don't move to the left or you don't move to the right. So the distance moved is 0, so the absolute value of 0 is 0. +4, the absolute value of +4 Well, that's the equivalent of moving 4 units to the right of 0. So let's draw our number line, mark 0, and count 4 spaces. 1, 2, 3, 4. Here it is. What distance did we move? We moved 4 spaces. So the absolute value of 4 is 4. Now notice that we get the same answer if we take the absolute value of -4, that becomes +4 because distance is a non-negative number. If we take the absolute value of +4, that stays +4 because distance is a non-negative number. So go ahead and hit pause, take a minute to find the distance represented by these absolute value expressions, all right? Okay, welcome back. Letter D. This says this is equivalent to finding the distance at 6 units to the left of 0. So -1, -2, -3, -4, -5, -6. How many spaces did I move? I moved a total of 6 spaces. Yes, we moved in the left direction, but distance is non-negative. The absolute value of +6, well, I'm going to mark 0 here and count 6 spaces to the right. Why to the right? Because this is positive on the inside. 1, 2, 3, 4, 5, 6. Here's my mark. 6 units. Again, we get the same value. Okay. Now what about F? Absolute value of 2 minus 7. Well, simplify what's inside the bars, and you get the absolute value of -5. So mark 0 and count 5 spaces to the left. Here's -5. How many spaces did I move? 5 spaces. So the absolute value of -5 is 5 units. Our third objective is to add, subtract, multiply, and divide, do all the operations on there. So just like we did with that last example, F, if you need to simplify inside the bars first, do that. Simplify inside the bars first. Then remove the bars by taking distance, just like we did. Okay, and then follow the order of operations that we have used so many times in the past. So here we go. Let's do a couple of these. All right, on letter G, we're doing addition. But first, I have to either simplify and or take the distance. So I don't really need to simplify. I just need to take the distance of the absolute value of -6, and that gives me 6. And then I'm adding it to the distance of the absolute value of 3, which is 3. And 6 plus 3 is equal to 9. On H, we're going to do subtraction. So we keep this as a subtraction, but the absolute value of 6 is a distance of 6. The absolute value of 3 is a distance of 3, so 6 minus 3 is equal to 3. For multiplication, again, we start at the same place. All right, look inside those bars. Can you simplify? In this case, we can. This stays -3, but I can simplify -6 plus 10 as the absolute value of 4. So this becomes -3 times the absolute value of 4 is a distance of 4. 3 times 4 is equal to, and that's a -3 times 4, -12. The division is getting a little bit more complicated, more to do. I purposely did this. So you're going to start inside the bars on the numerator, and we're going to do multiplication first because that's the order of operations. So I get the absolute value of 15 minus 7 plus 2, that's all in the numerator, all over the absolute value of -10. The absolute value of 15 minus 7, that's 8. 8 plus 2 is 10. 10 over the absolute value of -10, which is +10, and I get a value of 1. Okay? So if you need to pause that and go back and think about that, do that. Also, I want you to hit pause and I want you to complete as many of these as you can. Set a time limit of about 3 minutes and see how many you can get done in 3 minutes, and then come back and check your work. All right, welcome back. I'm going to work through as many of these as I can. So I have the absolute value of 12. That has a distance of 12. Plus the absolute value of negative 8. That has a distance of 8. So 12 plus 8 is equal to 20. The absolute value of negative 7 is 7. That's its distance. Minus the absolute value of negative 5 has a distance of 5. So 7 minus 5 is equal to 2. Letter M. 10 is not an absolute value, so we keep it exactly as it is. 10 minus the absolute value of negative 10. Well, that's just 10. That's its distance is 10. So 10 minus 10 is equal to 0. Letter N, negative 18, that's not going to change because that's not an absolute value. And then the absolute value of 17, that's a distance of 17. So negative 18 plus 17 is negative 1. And then O is negative 4 over 5, and that's as simple as we can get. And P is equal to negative 4 times the absolute value of negative 4. Well, that's just 4. And negative 4 times 4 is negative 16. I hope you did well. If you have any questions or you're not sure about them, go back and try and listen to it again, or you can write your questions down and ask me tomorrow. Expanding objective 3, we want to use this idea of evaluating absolute values, go one step further and actually plug in values into the expression. So notice what this is telling us to do. It's saying evaluate the expression if, that's another way of saying given, x is equal to negative 8, y is equal to negative 6, z is equal to negative 3. So anywhere you see an x, a y, or a z, you're going to substitute in these values. Okay, so letter Q, we have the absolute value of x minus 8. So that's the absolute value of negative 8 because I'm substituting that in, minus 8. So that's the absolute value of negative 16. The absolute value of negative 16 has a distance of 16 units, so it becomes positive 16. Letter R, notice that I have this negative sign out in front. That does not change. Don't drop that. Don't think that the absolute value takes it away because it's not between the bars. So it's negative, and then I have 7 times, and then z is 3. So I have negative, and then the absolute value of 21, and that equals negative 21. So now hit pause, try one or both of these two examples, and then come back and check your work. Okay, here we go. I'm going to plug in, and I'm going to work my numerator, and then I'm going to work my denominator. So I have negative 3 times the absolute value of negative 8 all over the absolute value of negative 6. Lots of negatives going on here. The negative 3 doesn't change because it is not an absolute value. However, the absolute value of negative 8 is a distance of 8 units. The absolute value of negative 6 is a distance of 6 units. So I get negative 24 over 6, which equals negative 4. The last one, t, we're going to plug in negative 2, and then x is negative 8. Notice that that's out in front, so don't think you have to change the sign on that one. Now we have our absolute value bars, 3 times negative 6 plus 8. All right, so start on the inside, and we get negative 2 times negative 8. And then on the inside, I get negative 18 plus 8. That's negative 10. So now I get 16. That's negative 2 times negative 8. That's 16. Times the absolute value of negative 10. Well, that's just 10. So I get 160. All right. Okay, so that's the first video. I want you to watch the solving video, and then we're going to take a little self-assessment. So thanks for watching.